Hello friends, in today's question, a 10 kg block is resting on the horizontal surface. When the force is applied to it for 7 seconds, the variation of force F with time as shown, the coefficient of static and kinetic friction are both 0.5. So we have to find two things. Find the velocity of the block at t is equal to 4 seconds. And second, find the total time of the motion. So this is a 10 kg block, F force is being applied on it. And this is the graphical representation of the force. It's first increases from, let us call this as 0, 0 coordinate up till a point, and let us call this as point A and this point B, and its coordinate will be given as 4, 100. After that the force decreases and ultimately we are going to find out what's the total time for the motion. So let's find out the equation for the line AB. Say the line equation for AB, which we can write as y is equal to mx plus c. Here y is the force and x is the time and m is the slope. So we can write this as f is equal to slope. We are going to get this as 100 divided by 4 t and plus c. So for the calculation of c, we say at t is equal to 0, here the force is equal to 0, therefore c will be also equal to 0. Therefore we can write the equation for this is equal to f is equal to 100 upon 40. From here we can say that force is equal to 25t. This is the equation for the force. Now next we are going to find out the time at which the block F of 10 kg starts to move. Okay. You can say let the block start to move at t is equal to t1, and the condition for which the block will start moving will be when the applied force becomes equal to the frictional force. Okay. So this is a 10 kg block, F force is being applied on it, and this is frictional force Fr. So you can say for the motion of the block, F should be equal to Fr, and we can find out every value of Fr. Fr will be equal to, in the downward direction there will be 10g, upward there will be normal n, and so that will be mu multiplied by n, or we can say mu into 10 into g. So we can find out that Fr mu is given as 0.5, mass is 10 and g is 9.8. So Fr will be equal to 49 Newton. So F is equal to Fr, and the value of F at t is equal to t1, so we can write this as 25. t1 is equal to 49. So from here t1 will be equal to 49 divided by 25. So we get the time at which the motion is going to start is 1 point, I think it should be 76 seconds. So at this time the motion is of the block is going to start. Okay. You can say so here, therefore block will start to move at time t1, which is equal to 1.76 seconds. Now let us suppose as it starts to move, it is given the acceleration is a. Say let the acceleration of the block is equal to a. We can write this as, this is 10 kg F force, and we have frictional force Fr, and with a it is moving towards the right side in this direction. Therefore we can write the equation for motion as F minus Fr will be equal to ma, so which basically means 10a. So here we can say acceleration a will be equal to F minus Fr divided by 10, and applied force is our 25t minus Fr is our 49, this divided by 10. Therefore we can convert into form the velocity, that dv by dt is equal to 1 by 10 25t minus 49. Now let us suppose at t is equal to 4 seconds, the velocity is given as Vmax. Say let at time t is equal to 4 seconds, velocity, we can say, velocity is given as Vmax. Therefore we can integrate it 0 to Vmax, dv is equal to 1.10, and the motion starts at 1.76 and it stops at 4 for this particular equation. So this will be 25t minus 49 dt. Okay. So this will be coming as Vmax minus 0 is equal to 1/10, and it is 1.96. Okay, my mistake. 1.96, and this will be also 1.96. Okay. So we can say this will be equal to 25 t square upon 2 minus 49t, and this will be 1.96 up to 4. So we write this as Vmax is equal to 1/10. This is 25, and upper is 4 square divided by 2 minus 49 multiplied by 4 minus, and the lower one is 25, 1.96 whole square divided by 2 minus 49, 1.96. So we can write this as Vmax equal to 1/10. This is our 200 and minus 196 which will be equal to, sorry, first part and the second part is 48.02 minus 96. So from here you can directly write it as Vmax will be coming equal to as 5.2 meter per second. Okay. So this is the maximum velocity at t is equal to 4 seconds. This is the maximum velocity of the block at t is equal to 4 seconds. Now after t is equal to 4 seconds, you can clearly say that there is change in the graphical. So this is at 4 seconds. After this, suddenly the force decreases, and for 4 and 7 it is close to 40 Newton. Okay. So let us divide for the time which is greater than 4 seconds but less than 7 seconds. You can say for t greater than 4 but less than 7, and obviously it will be resulting in the deceleration motion. Okay. So you can say the block is in retardation. Okay. And let us suppose the retardation is given as A1 for this 10 kg force F, and we have Fr, and as it is retardation, so force of friction will be greater than the force of applied force. So we can write the equation as Fr minus F will be equal to 10A1. So from here we can say A1 is equal to Fr minus F divided by 10. And we get A1 is equal to Fr, we already know, is 49, and the value of force at this particular moment is 40. So substitute here, divided by 10. So from here we get acceleration A is equal to 0.9 meter per second square. Now let us find out the velocity. Okay, if v1 is a velocity, say if v1 is the final velocity, then we can write v1 is equal to u plus at, and u is equal to 0. So we can write that we are going to get this as 0, and it is a, you can say, retardation, so this will be minus 0.9 and multiply by sorry, I made a mistake, u is not equal to 0. Okay, let me put it again, because as the block is already in motion, okay, so initial velocity will be equal to the maximum velocity. You can say as the block is already in motion, therefore u will be equal to Vmax, and which is coming equal to as, I think it was 5.2. So we can write that V1 is equal to u plus A1t, and this is 5.2, this will be minus, and this will be 0.9, and time will be 7 minus 4. So from here you can write that our V1 will be coming equal to a 2.5 meter per second. Now we come to the next part, when time is greater than 7 seconds. You can say for t is greater than 7 seconds. And once again it will be a retardation motion. So you can say for the retardation equal to A2, and the applied force is 0. The applied force F is equal to 0. Therefore, now the equation becomes Fr is equal to 10 multiplied by A2. So from A2 we get our Fr upon 10. Fr we know it is 49 divided by 10. So we can write that our A2 is equal to 4.9 meter per second square. And we suppose let the final velocity is V2. Okay. You can say let the final velocity is V2, which will be equal to 0, as it will be coming to stop. So we can write the equation as V2 is equal to U plus A2 multiplied by time t, and V2 will be equal to 0, and we have, now in this case U will be equal to V1 and U will be equal to V1. So this will be 2.5 minus 4.9, and time will be equal to, let us suppose t is equal to t2. So we can say t2 will be equal to 2.5 divided by 4.9. So this gives us that t2 will be equal to 0.5. Now let us find out the total time. So total time is given as capital T. So let us draw so here the motion starts at t is equal to 1.96, and then there is a change at t is equal to 4 seconds. Next change happens at t is equal to 7 seconds, and finally it comes to stop at t is equal to 0.5. So here v is equal to 0. Okay, here the velocity was 2.5, here it was 5.2, and here the initial velocity was 0. Therefore we can write the total time t, this t will be equal to the first part, which is 4 minus 1.96, plus second part 7 minus 4 and plus 0.5. Therefore this t will be coming as 5.55 seconds. So this is the total time for which the block will be in motion. This is the total time for which block will be in motion. So this completes the question. Thank you.